Okay, let's get right into it. Today, we're talking about a super simple but incredibly powerful math tool that shows you a hidden world of choices that's all around us every single day.
So, let's start with something we've all been through. Picture this. You're at the cafeteria, you're hungry, and you're staring up at the menu. You ever wonder just how many different meal combinations are actually possible? It seems like a lot, and counting them one by one would be a nightmare. But there's a shortcut.
Okay, here are your options for today. You've got 4 soups, 3 fish menus, 5 desserts, and 4 different drinks. Now, you could sit there with a pen and paper and try to write down every single combination, but, who has that kind of time? There has to be a better way. And that better way has a kind of fancy name, the fundamental counting principle. Now, the definition sounds a little dry, I know. A method to determine possibilities by multiplying outcomes. But don't let the formal language fool you. The actual idea behind it is incredibly simple. And here it is. This is the whole secret, boiled down to its essence. All that academic language just means this. If you have a series of choices to make, you just multiply the number of options at each step. That's it. So let's go back to our lunch problem and solve it. We take our choices, right? 4 for the soup, 3 for the fish, 5 for dessert, and 4 for the drinks. We just multiply them all together. 4 times 3 times 5 times 4, and bam, 240. There are 240 possible lunch combinations. No lists, no headaches, just a quick multiplication. Okay, so that was pretty straightforward. But what happens when we add a little twist? What happens when you can only use each choice once? This brings us to our first big rule: no repeats. So, let's try a little puzzle. We've got 5 digits here. 1, 2, 4, 7, and 9. The question is, how many different 3-digit numbers can we make? But here's the catch, the really important part. Each digit can only be used once. All right, let's break this down together. We're making a 3-digit number, so think of it as 3 empty slots we need to fill. For that first slot, the hundreds place, we can pick any of our 5 numbers, so we've got 5 choices to start things off. Now let's move to the second slot, the tens place. Since we've already used one of our digits for the first spot, and the rule is no repeats, we only have 4 digits left to choose from. See how our options are getting smaller? And you can probably guess what's next. For that last slot, the units place, we've already used up 2 of our digits. That leaves us with just 3 choices remaining. So we just multiply it out. 5 times 4 times 3, which gives us 60. There are 60 possible numbers we can make. Okay, so that's how it works when you can't reuse things. But let's flip the script. What happens when you can use your choices over and over again? Well, welcome to the world of repeats allowed. And this slide really nails the difference. With no repeats, your pool of options gets smaller with every choice you make. It's like you're pulling items out of a bag. But when repeats are allowed, the number of options stays exactly the same for every single step. It's a small change in the rules, but it has a huge effect on the outcome. So let's run that number problem back, but this time we can reuse the digits as much as we want. For the first digit, we have 5 choices. For the second digit, we still have 5 choices because we can just use the same one again. And for the third, you got it, 5 choices again. So we get 5 times 5 times 5, which is 125 possible combinations. That's more than double what we got before. Now, you might be thinking, okay, that's kind of cool for lunch and number puzzles, but here's where this gets really powerful. This isn't just a math exercise. This principle is working behind the scenes in some incredibly high-stakes situations. Things like lotteries, locker combinations, and even license plates. And this quote from the source material is pretty telling. It hints that when you apply this principle to something like the lottery, the answer you get might be a very, very compelling reason to save your money. Let's see exactly why. So in a Mega Lotto 645 game, the rules are you have to pick 6 times unique numbers from a pool of 45. That word unique is the key. It means we're in a no repeat situation. So the question is, how many different ways can you pick those 6 numbers? You might want to sit down for this. The total number of possible combinations is over 5.8 times billion. That is the number you are up against every time you buy a ticket. The fundamental counting principle just makes the staggering odds crystal clear. Okay, let's try a different real-world challenge. We've all been there. You're standing in front of your locker, and your mind is a complete blank. You can't remember the combination. Can our principal tell us how much trouble you're actually in? So, let's say your lock uses 3 different numbers on a dial that goes from 0 to 35. That's another no repeats problem. For your first number, you have 36 choices. For the second, since you can't repeat, you're down to 35. And for the third, just 34. Multiply those together, and you get 42,840 possible combinations.
So what does that number mean in the real world? Well, if you could try one new combination every 12 seconds, which is pretty fast, it would still take you almost 6 full days of nonstop trying to guarantee you could open it. Yikes.
And this is where it just scales up to mind-boggling levels. Think about something like a license plate with its mix of letters and numbers. Or think about all the requirements for a strong computer password. The number of possibilities becomes absolutely astronomical. This simple principle is literally the foundation of modern security. So let's just wrap up with the key takeaways here. First, to find the total number of outcomes, all you have to do is multiply the possibilities for each event. Second, the most important question you have to ask yourself is, can the choices be repeated or not? And finally, remember that this simple idea is everywhere. It's shaping everything from your lunch options to the odds of winning the lottery. At the end of the day, the fundamental counting principle really gives you a new lens to see the world through. So I'll leave you with this question. Now that you know the secret, how many of these invisible calculations are you going to start seeing that shape your day?